Okay, this is not a fun assignment. It seems rather pointless, okay, when you first do it, but it builds up skills. It says y equals 3x minus 3 divided by x second minus 1. This is a rational function because we have an x in the denominator on the bottom, okay? It's a rational function. Okay, now there's some things about rational functions before we get to the graph we have to know. Vertical asymptotes. This is what a vertical asymptote is. Okay. Vertical asymptote is this is a graph. A vertical asymptote is an imaginary vertical line that the graph can never cross. Okay, we've seen horizontal before, but never vertical. Okay, they're expressed as x equals. I know they're the opposite of what the y-axis is. Okay. Again, the graph will never be on those points. Now here's how we figure them out. First off, you write y equals. Now, up here, you need to take these expressions. If you have minuses, you need to put them in parentheses. Minuses or pluses, because those are binomials or trinomials. They're more than one term, okay? So on your scratch paper, make a denominator, you write 3x minus 3 down, and that's two terms, okay? So it's GCF and DOPS. Okay, so I don't have the x, don't have the negative. 3 and 3 would be 3, and I would divide by 3, and that's 1x minus 1. So I bring down the 3 GCF, don't want that there, okay? Cross it off. Now, the 1 in front of the x can go. That's a minus, but it's not perfect squares because the x isn't to an even power. So no. And you bring down the quantity x minus 1. Now you go over here and you replace that with 3 times the quantity x minus 1. The next second minus 1, I do the same thing. Okay. It's another binomial, two terms. So it'd be GCF and DOPS, okay. GCF's 1, don't need it. You have the minus, you can take the 1 off the front. It's x times x, 1 times 1. So x, 1, 1. Okay, so I bring down x plus 1 times x minus 1. There's no GCF, I just bring those down. I will be replacing this. This is what will be in my numerator. Okay, now the vertical asymptotes can be found by setting the factors in the denominator equal to 0. X plus 1 equals 0, x minus 1 equals 0. So minus 1, you show your work too when doing this, rather than mentally, just trust me, okay? And I would get 1. Now, here's what a hole in the graph is. If you have a parentheses on top, a common factor on top that you have on bottom, which we have with this x minus 1, we get rid of those. And do you see that x minus 1 equals 0 where I got 1? Do you see it? Okay, that one I just crossed out of the bottom. X minus 1 equals 0. Okay. What you need to do is cross that out. That's no longer an asymptote because that factor is no longer there. 1 is known as a hole in the graph now. Okay. And again, the whole reason why we set the bottom equal to 0 because we can't have 0 in the denominator. We're essentially finding the asymptote. Remember, the asymptote's the line you can't cross. Okay. Now the horizontal asymptote, this is what you do. It's expressed as y equals. So what you need to do, not write out the whole thing. You write y equals. And you take the first term from the numerator and the first term in the denominator, 3x over x to the second, then you simplify. Now the 3 doesn't simplify, but x1 and x2, I take out the x1, minus it, and I have 1 still on the bottom. So I have x on the bottom. That's what we need to know. X is on the bottom. The answer to this is 0, and here's why. Because if you pick an insanely high number and substitute it for x, let's say 200,000, and I take 3 divided by 200,000, I approach 0. Okay, if I take 3 divided by 2 million, I approach 0. Okay, that's how that works. If x ends up on the bottom, your horizontal asymptote is going to be 0. If it's on top, if the x ends up on top, then there's not going to be a horizontal asymptote. You would write none. Okay, X-intercepts. You're going to make a coordinate right there with an xy. This would be where the actual graph crosses the x-axis. You find it by setting your y equal to 0. But you don't want to go with the original when you're finding the intercepts. You go with your new one. So I have y equals, I have 3, and these have been canceled over the parentheses x plus 1. So I'm going to copy that down. You want to go with the simplified form of what you did, not the original, if you were able to simplify it. Now take your y out, replace it with 0. Okay? Now, you can put a 0 under the 1, and then you find your cross products, but this is really easy. Okay? Now I don't care, I don't distribute a 0. 0 times any parentheses is 0 on that side. Now on the other side we take 3 times 1, and that's 3. Now I'm solving for x, but the x went away, and if the x goes away, that means you write none. Okay? None. If you end up with 0 and then another number, the x is bye-bye, it's none. Now in the y-intercept, make that xy parentheses, and you set the x to 0 with your simplified function. So I write my simplified function, and I'm going to substitute 0 in for x. Now parentheses 0 plus 1 is 1. Then 3 divided by 1 is 3. So I do have a y-intercept. It would be 3. Now the domain is easy. You look at your asymptotes and holes. So that means x can be anything on this graph, but it cannot not equal to negative 1. You put an equals with a line through it, and it cannot equal 1. Okay? Those are the two things it can't be equal to, because that would make the denominator a 0, and you can't have 0 in the denominator. Okay, next problem. Y equals negative 3x plus 6 over x to the second minus 5x plus 6. Okay. First off, vertical asymptotes. First you need to factor. 2 terms on top, 2 terms on bottom. Try to factor those expressions. So negative 3x plus 6, that's a binomial. So it'd be GCF and then DOPS. Difference of perfect squares. There's no x, there is a negative. 3 and 6 is 3. Okay, so it's going to give me 1x and negative 2. So bring your negative 3 down. Now see if that's a DOPS. Take the 1 off. Well, it's not again, because x minus 2 is not perfect squares. So I rewrite this as negative 3 times the quantity x minus 2. Now in the denominator, we have a trinomial. X second minus 5x plus 6. Okay, so that's a trinomial. So it would be GCF and the t chart. Okay, so I don't have an x, I don't have a negative. 1, 5, and 6 is 1. And then 1 times 6 gives you 6, positive 6. So it's a match. Negative, negative, it has to add to negative 5. 1 and 6 doesn't do that. And somebody's like, well, could you make the 1 a positive? No, it has to be a match. Okay, that's negative 7, so that doesn't work. 6 divided by 2 is 3. There's my negative 5. A is 1x to the second, so take the 1 off the front. You got x, and then negative 2, negative 3, or 1. Put the 1 there, my bad. Okay. You really can't divide those, so I guess I don't need the 1. You can divide, but it'd just be by 1. Okay, that's what you have. You didn't do the GCF, so it's x minus 2, x minus 3. You're rewriting this and replacing it with this. So the asymptotes, I set the bottom factors equal to 0, not the top. Your vertical asymptote is what you're finding where the x in these would be, where you would be dividing by a 0. So x minus 2 equals 0, x minus 3 equals 0. So you plus 2, you get 2. Plus 3, you get 3. Now to find your holes, you have to simplify if you can, which we can. The x minus 2's cancel out, okay? So you see that x minus 2 where I got the 2, that's no longer an asymptote, that's a hole. Okay, horizontal asymptote, you're finding what the y would equal, okay? Like the line you can't cross, okay? Now, I've already explained the shortcut for that. Just take your first two terms, the negative 3x over the x to the second. Now the negative 3 is going nowhere, but the x1, x2, x1 goes away. And I have my x is down on the bottom again, meaning that my horizontal asymptote is 0. Okay. Now the x-intercept, you put that as a coordinate with the y equal to 0. Then you go up and write the simplified form without the x minus 2's that you crossed out, because you want a simple equation to get your x and y intercept. Okay, so I'm going to copy that down. And y is replaced with 0. Now you can put that over 1. Now 0 times anything, I don't care if what's on the other side, the whole side 0. And then 3 times 1 is negative 3. So I'm trying to find the x value, but now the x is gone, so that means none. Okay. Alright, now the y-intercept, same idea. But now to find the y-intercept, we put the x to 0 so that I can solve for y. So, using that simplified function, and I so x minus 3, I'm getting that from up here, so x is replaced with 0. 0 minus 3 is negative 3, okay, so we have negative 3 divided by negative 3, and that's 1, so y equals 1. Okay, now your domain, you're just writing what x cannot be. It can't be 3, it can't be 2. It's not equal to 3, it can't be equal to 2. That's what asymptotes and holes are. They eliminate that point out of the domain of the graph. The graph will never have an x value of 3 or 2. Anything else you could have the x value, but not that one. Because if you have 2 in for x, 2 minus 2 is 0. If you have 3 in, 3 minus 3 is 0. And you can't have a 0 in the denominator, because look what happens. 8 divided by 0 is a domain error. Okay, next problem. Y equals 3 is just one term. Don't put it in parentheses. You just bring that down if it's just one single term. But this right here is 2 terms. We take that onto the scratch paper. 1x to the second minus 2x. So GCF and DOPS. Okay, I have x on the end. No negative. 1 and 2 is 1. So then I divide by 1x. Okay. 1 divided by 1 is 1. X second divided by x, so this is a remainder of x, and negative 2, and those cancel. So I bring the 1x down. Okay. Take the 1 off the front. This is not a difference of perfect squares, so no. So you bring down the x minus 2. Get that 1 off the front of the x. Even if it's a GCF, so you replace this with x, parentheses, x minus 2. Okay. Vertical asymptotes. You take each factor in the denominator, the x and the x minus 2, and you set that equal to 0. Well, that one's already done. Over here I add 2, I get 2. Now the holes. Now you're going to have no holes because you can't cross anything out. Okay, and if you can't cross anything out, then there's no holes. You write none. See? Okay, horizontal asymptotes. Y equals. That's verticals are expressed as x's. Y's are horizontal this way. That's expressed as y's. It's like the opposite of the axis. all you do is take the first term on top, the only term, and then you can put x to the second power, okay? Don't put the 1 with it, okay? X is on bottom, so we're going to have a y asymptote, a horizontal asymptote is 0, okay? Now the X-intercept. Now, I didn't do any crossing out, so this is what I write down. Since I did not cross out, I don't go rewrite it over there. I was not able to cross out, so that is what I'm using to find my X and Y intercepts. So the X-intercept, you set y equal to 0. Now copy that down. So y equals 3, and then x times x minus 2. Put your y to 0. Then put a 1 under it so you think of it as a proportion. Now again, 0 times, I don't care what that crap is, when you times it by 0, it's 0. I don't care if there's letters, numbers, whatever the heck. 3 times 1 is 3. So I'm supposed to be finding a number for x, but x went bye-bye. Okay, so that's none. Okay, now the y-intercept. That's a coordinate where the x is 0, so I can solve for y. So I use this function here. Just write it down, then we'll talk. And you put 0 in for the x's, and that means both of these things. Okay, so 0. Now 0 minus negative 2 is negative 2, so I have 3 divided by 0 times negative 2. 0 divided by negative 2 is 0. So y equals 3 divided by 0. Take your calculator and divide 3 by 0. It says error. So when you do that division, you get error. That means you also have none on the y-intercept. Okay? The graph wouldn't never cross the x or the y. Okay, domain, you just take your look at your vertical and your holes. There were no holes, but I have 2 vertical asymptotes. You're just looking up here. So x could never be equal to 0. It could never be equal to 2. Okay. Asymptotes essentially is what x can never be equal, and the horizontal is what the y will never be equal. Okay, next problem. Y equals x to the second power plus 2x over x plus 2. Okay. First off, vertical asymptotes. First we have to factor the expression. Okay. That's 2 terms, and that's 2 terms. Okay, so neither one of them have a single. If it's a single term, you just drop it, but if there's 2 or 3, you need to see if it can factor. So on top, 1x to the second power plus 2x. 2 terms, that would be GCF. And then a difference of perfect squares. Okay, x is on the end, negative 1 and 1, so 1x. X, and then plus 2, and that cancels. Okay, so you bring that 1x down. You don't need the 1 anymore. That it's a plus, it can't be a dot. So take the stupid 1 off those, so it's x times x plus 2. So we rewrite this as x times x plus 2. No 1's in front of x's. Any other number you keep there, but not the 1. Now 1x plus 2. I put the 1 there initially so I can see what I'm factoring. Okay, but in the end I take the 1's off the front. So GCF dots, it's 2 terms. Problem here, there's no x, there's no negative, and then it'd just be 1, which we never do. And that's not a dot, so I didn't do anything with this, okay? So all I do is just bring over, take the 1 off the x, and you would just keep it the same. X plus 2. Put a parentheses around it, though, since it has 2 terms. Okay, vertical asymptotes. You set the what's on the bottom, x plus 2 equals 0. Minus 2, you get negative 2. I think that's a vertical, but then when I do my holes, if I cross out something, I end up taking it away. So we can cross this out. So here's x plus 2 that I just crossed out. Okay, I got negative 2. So you take the negative 2 out of the vertical asymptote section and put it in the hole section. So, and you're like, well, what's my vertical asymptote? None. Okay. Okay, now, horizontal asymptote, okay? Again, you're doing the same thing. You do the horizontal asymptote the same every time, okay? You put your, go up to your original, you put your 1x second over your 1x, just the first two terms, all you need. Okay, now look at the x's. The x's are where you got to look, okay? So I get rid of that, minus 1, and that's going to be 1. Where's the x end up at, top or bottom? On top. If it ends up on the top, then there is no horizontal asymptote, okay? Because you see there's not that limit anymore. Because you remember when I pick an insanely high number on the bottom and divide the top by the bottom, I get 0. But now the x, I'll pick an insanely high number for the top. I'll take 1 times 200,000. That doesn't approach anything. It just gets infinitely higher. So if the x is on top in the numerator, it's none. Now the x-intercept, okay? Put your y to 0 and write your simplified, which is just y equals x, so that's a simple one. Okay, take your y out, replace it with 0, and 0 equals x, so there is going to be an x-intercept at 0. Okay, the x is still there, okay, 0. You don't have a fraction anymore. Okay, y-intercept, copy that down, okay. Now you're putting the x to 0. Put your 0 in for x, and now y equals 0. So essentially the y and x-intercept, y-intercept are the same, because that's in the middle of a graph. That's on the x and y axis at the same time. So the domain, well, we didn't have anything there. X would never be able to equal to negative 2. That's the only x value you don't have. Okay, y equals 3 over x plus 2, okay? So, I would not parenthesize that, it's only one term, okay? 3 is one term, you don't put that in parentheses. This is two terms, put it in parentheses. The 1x and the 2. Okay, now. So, 1x plus 2. Can I factor that? I don't think I can because it's GCF. DOPS would be the properties you use to try to factor it. No x, negative, it's just 1. Okay. Plus, well, we got a plus, so that would be no. So then you take the 1 off the front and just leave it the same. Okay. So x plus 2. So that vertical asymptotes, you go x plus 2 equals 0. So I would subtract 2 and I would get negative 2. Okay. Now, does that stay an asymptote or does it become a hole? Well, we're not canceling anything out. And if I'm not canceling out anything, then that would stay an asymptote and it would be none on the holes. Horizontal asymptote, okay, y equals, you just take that 3, don't put the 1 in front of the x, just put 3 over x. Okay. Well, x is on bottom, so now we're back to actually having a horizontal asymptote that equals 0. Okay. Now, x-intercept, you make a coordinate and you put 0 in for y. Okay. At the x-intercept, the y is 0. Now, you didn't cross anything out, so that's what we're going to use. Y equals 3 over the quantity x plus 2. Now put 0 in for y. Okay, so it's a proportion, but it's an easy proportion because product is 0 and anything 0, and 1 times 3 is 3. Well, I got to solve for x. It's not here, so that's a none. Okay. Now the y-intercept, set up another coordinate. Okay. Now the x is 0. Use that as the simplest function you have. Okay. Then x plus 2, replace your x with 0. Now this isn't a proportion. This is just straight math, operational math. 0 plus 2 is 2, so that's 3 over 2. 3 divided by 2 is 1.5. So yeah, the y-intercept is 1.5. Okay, circle none. If you write none, circle it. Okay. Domain, x would not be able to be equal to -2. Okay, y equals x plus 3 over 2x to the second power plus x minus 3. Okay, so that's 2 terms on top, that's 3 terms on bottom. Let's see if we can factor them. So 1x plus 3. So it's 2 terms, so it'd be GCF and DOPS, if this is even possible. One's a GCF and it's not a DOPS. So take the 1 off the front and just leave it. So this stays x plus 3. Now the trinomial in the denominator, you have 2x to the second power plus x minus 3. That's 3 terms, so that's a trinomial. So GCF and T-table. Okay. Now x on the negative in front, 2, 1, and 3 is 1. Okay. So 2 times -3 is -6. So that's a mismatch. Positive, negative. It's got to add to +1. 1 and 6, that's -1. 6 divided by 2 is 3. You can stop dividing. That's -1 to make it positive. You go +3, -2. Okay, so A equals 2x to the second. Okay, so -2, +3. And we know we're going x times x, but the 2 means I need to apply the 2 and then simplify it. 2 and 2 would divide by 2, and this would just stay the same. 2x plus 3, then 1x minus 1. Okay. So no GCF, so you take, that 2 you divided by does not come to the outside. That is deleted. This whole thing is deleted, okay? Because this is the correct factoring. I mean, look at 1x, 2x, 2x second, -1, 3 is -3. So replace this with this. So x minus 1, 2x plus 3. Okay, so the vertical asymptote sits at your bottom. You set your bottom factors with x equal to 0. So x minus 1 could equal 0, 2x plus 3 could equal 0. So add 1, we get 1. Minus 3. Now, we take away the asymptote sometime depending on what I can cancel. -1.5. But I can't cancel a darn thing. The parentheses don't match up. So if you can't match up anything, then there are no holes. None. Okay. So the horizontal asymptote y equals. So you put your 1x over your 2x to the second. Don't put the 1 in front of the x, just put x over 2x second. Okay. Now look at your x's, that's the key point. Okay. You take out the smaller x, minus 1 from the bottom. So there's an x still on bottom, but it's on bottom, which means the horizontal asymptote is equal to 0. Now the x-intercept. Well, we couldn't cross out anything, so that's what we're going with. Okay. And we are. So your xy, put a 0 in the y coordinate, copy that down, okay? And we'll be scratching out the y and putting it in with 0. Now it looks like a lot of work, but it's not as much work as you think it might be. 0 over 1. Now this cross product is 0. I could care less what's in the crap in the other part. 0. Now, over here, we actually have to distribute. You take the 1 times the x, which is 1x, and then you take the 1 times the 3. It's a distributed property. So that's 3. Well, now x did not go bye-bye. It's away, so I solve for it. Take the 1 off the front. You got to subtract 3, and we actually have an x-intercept. -3 would equal x. Okay? All right there. I'm going to let you know a little secret about the x-intercept in the next problem. Make it go a little faster. Now the y-intercept, okay? Y-intercept, the x would be equal to 0. And we use that function there. And we are putting x equal to 0. That means every x I see is replaced with 0. Okay? 0, 2 times 0. Okay? Now, y equals, now we got to get rid of 0 plus 3 is 3. On the bottom, 0 plus 1 is 1 times, and then 2 times 0 is 0, but plus 3 is 3. So 1 times 3 is 3, and then y ends up equal to 1. So I do have a y-intercept at 1. Now the domain, okay, that's your vertical and holes. X cannot be equal to 1. It cannot be equal to negative 1.5. There is no holes. Okay. All right, next problem. You got 3 terms here, 3 terms there, so you want to definitely try to factor this. Okay. So x to the second, 1x second, plus 1x minus 6. So that's 3 terms. So it would be GCF and the t-chart. 1's your GCF. ABC that. 1 times negative 6 is negative 6. Okay. Positive, negative. It's got to add to positive 1. 1 and 6, nope. 6 divided by 2 is 3. That's negative 1. Make it positive. Okay, your A is 1x to the second, 1x second. So you put in your negative 2, your positive 3. You got XX. Now we have a 1, so you can put the 1, but you can't really do anything with those. So we end up just taking the 1's away. Okay. No GCF. So we rewrite this as x minus 2 and x plus 3. Now in the denominator we have a trinomial too, 3 terms. X to the second plus 2x minus 3. Okay, so GCF and the table. 1's your GCF, ABC. It's going to be negative 3. So it's a mismatch, positive, negative, okay? It's got to add to positive 2. 1 and 3, that's negative 2, flip it around. So A equals 1x to the second power. Okay, so x times x. You can place a 1 in front. Okay, 1 and 1, you're not going to be able to divide that. So there's no GCF, so we're going to put x minus 1 and x plus 3. Okay, asymptotes, you set the denominators equal to 0. The denominators factors, the bottoms factors. So x equals 1, x equals negative 3. Now the holes, can you get rid of, oh I can, an x plus 3. So you see that x plus 3, that became negative 3. Cross that out, and that's a hole. Okay, horizontal asymptotes. Y equals, all you do is look at the original, okay? And you take the first term from each of your quantities. Don't put the 1's in front. Just put x second, x second. Now this is going to change, okay? What happens if they're of the same degree, okay? Well, then they both wipe out and you get 1. So the horizontal asymptote's 1, okay? Now we're going to start describe, and now X-intercept. So y 0. Now we cross some things out, so we're just going with y equals the quantity x minus 2 over the quantity x minus 1. Okay. So put 0 in for your y. Or I'll write it first so you can see it happen on the spot. 0 replaces y. Now, here's what you can do. Here's a shortcut, okay? If this is equal to 0, it only works if it's equal to 0, okay? I said again, it only works if it equals to 0. You can take this out and just write 0 equals x minus 2 and solve for x. So plus 2, x equals 2. That's a shortcut to find the x-intercept, because you're going to be setting the y to 0, so really you can just set the top equal to 0 and then solve it from there, and that always will work, okay? Rather than the cross multiplication crap, okay? Y-intercept, x to 0 on the y-intercept. Remember, you want to use your simplified function, okay? So all these x's are replaced with 0. Now we're putting 0 in for the x's. If there's more than one, well, then they both go. So what's 0 minus 2? Be negative 2. 0 minus 1 is negative 1. So negative 2 divided by negative 1 is positive 2. So y is equal to 2. Okay. So there was an x and y-intercept domain. X would not be able to be equal to 1. It would not be able to equal 3. Negative 3. Okay.